Welcome to another tutorial. In this video, we're going to check how can you be able to find the y dx of tan inverse of a function. So in order to work out this, these are the steps we're going to follow. We're going to say if y equals to tan inverse of a half x, so it also means that tan y equals to a half x. Then now, since y is a function of x, we're going to differentiate both sides and we're going to use implicit differentiation. And in order to do this, we're going to say that we need to differentiate both sides of this function tan y equals to a half x. So tan y is a function of x, so we're going to get sec squared y. So if you differentiate tan y, you are going to get sec squared y. Now, since we have differentiated y and y is a function of x, we're going to include dy dx at this particular point. And we're going to go on the other side. If you differentiate a half x, what are you going to get? You're going to get a half. So the next thing we're going to do is to divide both sides by the z squared y, and then we shall have now our dy dx equals to a half 1 over sec squared y. But remember, 1 plus tan squared x equals to sec squared x. So which means this part we can be able to replace with tan squared. But now in terms of y, our dy dx is going to be equal to 1 over 1 plus tan squared y. But remember, tan squared y can be expressed in terms of a half x, because initially tan y we had said is a half x. So which means tan squared y we're going to replace with this, and we shall have dy dx equals to 1 over 1 plus a half x, now squared because our tan was squared. So at this given point, we're going to have dy dx equals to 1 over 1 plus, that is now x squared over 4. Now to remove this fraction at the denominator, because we are having x squared over 4, we can multiply both sides by 4. That is both at the denominator and at the numerator. We shall multiply by 4 in order to get that rid of that fraction. And we shall multiply at this particular point by 4, multiply there, and this one also multiplied by 4. Now, if you open the brackets, you are going to have dy dx equals to 4 plus x squared. And whatever we have now is the differential function of tan inverse half x. So you can be able to follow through using other questions so that you can be able to prepare well for your exam. So if you found value in this video, consider subscribing and also give this video a thumbs up.